let's go over this really quickly and then we'll go over any questions from homework. There were a couple that I noticed. So this is basically just giving you x's and y's. And if it wants the slope, it actually, or rate of change, is just basically asking for the slope. So rate of change is a way to talk about slope when you're talking about different units. So in this case, they're talking about the years and the centimeters compared. And for these, I think they flipped them. And so when I show you the answers, it's actually going to be centimeters per year. So you may have gotten the reciprocal of that, but that's okay. So just because I didn't want to put it out of order and have y's and then x's, but they flipped them and said how many centimeters per year. So yours might be reciprocated, which is fine. What you're going to do is you are going to take your x's and your y's and subtract them just like you would do for slope. So if you did it the way I have it set up for x's and y's, they want 0 to 2 years. And so your y's for 0, if this is my x, my y for 0 would be 50. So my point is 0, 50. That's what we're doing here, x's and y's. So if I take my y value and I say, oh, they did it the same way we did it, good. If I say my y2, which was going to be here, and say 86 minus my y1, which is there, over the two x's that they gave me, my x2 minus my x1. And so that's what I'm going to do across the board. All right, and so you should get equations of line can be written in different forms by applying the properties of equality. You've already learned the standard form. So we did the standard form of an equation, ax plus by equals c. We figured out how to get our x and y intercepts. So to get your x-intercept, you zero out your y and solve. To get your y-intercept, you zero out your x and solve. All right, and that was one way we did this, and one way we graphed. We found our two intercepts, and we graphed. The other way we've graphed is we have one point, and we walk with our slope. And so that's actually how we're going to graph something in slope-intercept form. When it's in standard form, it's often easier just to find your two intercepts as your 2 points and graph those. When it's in slope-intercept form, it is the same exact line, it's just written in a different form. Slope-intercept form is probably the most common form of a line equation you are going to see. And that starts now, and it goes through geometry, through Algebra II, standardized tests often like slope-intercept form questions. And so slope-intercept form is really one of the most common forms, and that's the handout that you have right here. Slope-intercept form. All right, it is y equals mx plus b. That is your slope-intercept form right here in this big box at the bottom. Y equals mx plus b. You'll notice that for y and x, they have the word variable written on them. Variable is written on those two. The reason the word variable is written on it right here and right here is that in the equation, those remain variables. So in your slope-intercept form, your y will actually be a y and your x will be an x. The m and the b will be filled in with numbers. All right, they will be filled in with numbers. So y and x stay variables, m and b are actually filled in with different types of numbers. So just like we talked about from our bell work, the slope is the rate of change. The slope is the rate of change. It is the rise over the run. The rise over the run. We've already talked about what y-intercept is. The y-intercept is the point where the line crosses the y-axis. All right, so when you hear the word y-intercept, it's where it crosses the y-axis. When we had it in standard form, ax plus by equals c, we had to solve for the y-intercept. We had to solve for it. We had to plug in a 0 for x and find it. But it is where it crosses the y-axis. So the formula for the equation of a line using its slope is its y-intercept. So you have a formula for the equation of the line using its slope and its y-intercept. So that's what slope-intercept is. It actually gives you the slope and the y-intercept. The m represents the slope. So when you have it in slope-intercept form and I say, what is the slope? You do not have to solve for it. You simply tell me whatever number is in front of the x. Whatever number is in front of the x is your slope if it is in slope-intercept form. The b represents the y-intercept. So when it's in slope-intercept form and I say, what is the y-intercept? You don't have to plug in a 0, because if you do, you're going to end up with that b, that constant that's at the end of your line. So when it's in slope-intercept form, you really just have these two pieces handed to you, and that's why it's called slope-intercept form, because you have the slope and the y-intercept just handed to you. You don't have to solve for anything to answer those questions. So we're going to look at the first example. They're going to give us standard form, and we are going to convert it to slope-intercept form, and then we're going to talk about what's our slope and what is our y-intercept. So they've given us this equation. This equation is in standard form. This is standard form. AX plus BY equals C. Okay? And they want us to change this over to slope-intercept. So slope-intercept has the y all by itself. The slope-intercept has the y on one side of the equation all by itself. Because of that, all we're going to do, think about when we did equations where they were all variables, and I said solve for this one specific variable. That's what we're going to do here. We're not actually going to come up with an answer that's like a number. We're just going to rewrite this equation so that the y is all by itself, okay? And so the first thing we're going to do is we're going to move anything out of the way that doesn't have a y in it. So there's a 3x there. We want to move that 3x across the equal sign, which means we need to add or subtract it. In this case, it's a positive 3x, so I'm going to move it across by subtracting a 3x from both sides. On the left-hand side, it just cancels out, and I am left with just that 2y. On the right-hand side, can I combine 6 and negative 3x? No, they are not like terms, so I can't combine that 6 and that 3 because the 3 has an x. When you write it, you want to always write the x part of it first, okay? So I'm going to start with that negative 3x, and this is a positive 6, so I'm going to write plus 6. All right, for slope-intercept form, you'll notice the x is listed first, all right? My y is still not by itself. What is with my y right now? A 2. And so it is being multiplied by a 2. I'm not going to add or subtract that 2 over. I'm going to divide it over. Dividing it here just gets the y by itself. I have to divide every single piece, though, by that 2. Every single piece. So on the left-hand side, I have a y. On the right-hand side, how I'm going to write this is I'm going to leave it as a fraction. So I'm going to say negative 3/2. If I could have reduced that fraction, or if it had turned into a whole number, I would have written it that way. But if it doesn't reduce, you're just going to leave it as an improper fraction. You don't even want to write it as a mixed number. So we're going to say negative 3/2 times x, and then we have 6 divided by 2. Well, that actually divides whole numbers, so I have a positive 3. And now I have it in slope-intercept form. I have moved my piece over, and I have divided by the coefficient of my y. So that's the first part of it. Write it in slope-intercept form. I did. I am done with that part of the question. The next part of the question says to state the slope and the y-intercept. Once it is in slope-intercept form, all you have to do is look at the equation. My slope. Well, my slope is represented by the number in front of x. So I'm just going to look at this equation, and I'm going to say, well, my slope is negative 3/2. That answers that piece. It also asks for my y-intercept. My y-intercept is a point. It's always going to have an x value of 0, and the y value of my slope-intercept is going to be right there, positive 3. And so my y-intercept is 0, 3. 0, 3. All right? So move everything out of the way. It says changing a linear equation to slope-intercept form. Solve for y. You're going to move anything that doesn't have a y over, and then you're going to divide by anything that is in front of the y. We have graphed using the standard form. Using the standard form, you find your x-intercept, you find your y-intercept, you plot those 2 points, and then you connect the lines. We've also graphed where they hand you a point, and then they give you the slope, and they say graph, and so you plot that 1 point, and then you use your slope to walk where you need to walk to your next point, all right? That's the method you're actually going to use for slope-intercept. The difference here is the point that you're going to start at will be your y-intercept because they've already given it to you. So they gave us this line here, y equals negative 3x plus 2. My first step is to place a point at the y-intercept. My y-intercept for this graph is going to be 0, 2. That is my b value, 0, 2. And so I'm going to go to the y-axis, positive 2, and I'm going to put that point there. So I'm going to put a point at my y-intercept. Remember, it's where it crosses the y-axis. The next step is from that point, you are counting using your slope. So I'm going to figure out what my slope is. My slope here is negative 3. That's the number in front of x. Now remember, every whole number has a denominator. What is it? It's positive 1. So if you want to think about this, now when I ask for slope, I just want the whole number. But to graph it, you want to think about the fact that it is going to be negative 3 over positive 1, or it is going to be positive 3 over negative 1, depending on, sometimes that positive 3 would take you off the graph, or sometimes a negative 3 would take you off the graph, and so you may have to flip those negatives, right? So you are going to walk this. I'm going to start here. And if it is negative 3 over positive 1, I'm going to say negative 3. That's my up and down. Negative is down. 1, 2, 3. Positive 1. That is right 1. And so I'm going to walk from my y-intercept down 1, 2, 3 and over 1. And then I'm going to put my next point right there. Anytime you have 2 points, you can graph your line. That's all you need. By definition, 2 points make a line. And so once I have 2 points on my graph, I can go ahead and get a straight edge. Typically is easier than trying to draw it without one. Line it up with your 2 points, connect your dots, and then draw arrows at the end. And you have graphed using your slope-intercept form. Now, if I had gone up 3, 1, 2, 3, and left 1, you could see that I would have crossed the same line. It creates the same line. All right. You also, just for visual, looking at this, you should know that going left to right, you should be going down. And so if you were to graph this and somehow you got it going up, your logic should kick in and say, I did something wrong. That negative 3 should be going down from left to right. Often in standard form, I would say, just find your intercepts and then go from there. But in this case, one of my intercepts is actually going to be a fraction. So my x-intercept here would be negative 3/2. And sometimes graphing a fraction can be difficult. And so you can put this in slope-intercept form and see if it's easier to graph that way. So if I were to put this in slope-intercept form, I would take that 2x and I would move it over. I would do just like I did on that first example. I'm going to subtract my 2x over. And I have 3y equals negative 2x minus 3. And then I'm going to divide everything by 3. All right. I'm going to simplify. Y equals negative 2/3 x minus 1. And then I'm going to graph. All right. And so where do I start then? Well, I'm going to start at my y-intercept. What is my y-intercept? Negative 1. So I'm going to put a point here. It's already there at negative 1. And then my slope. My slope is negative 2/3. I can either go down 2 and right 3, or I can go up 2 and left 3. They will give me the same line. So if I do the first one, down 1, 2, over 1, 2, 3, I will be at this point. If I chose to go the other direction, at this point you only need 1, but you can do either one. So up 2 and left 3. Either one will get you on the same line. And then you can connect any 2 dots will cause the line to form. But just to show you, because there will be times when doing it one way is easier. All right, so any questions on graphing? All right, given the line itself, you can actually come up with the equation in slope-intercept form. So I have the graph here. It's been given to me. If I want it in slope-intercept form, I automatically know that I am going to have y equals something, right? I need to figure out my slope. Well, my slope, if I start at 1 point, I should be able to count to the next point. They've given me 2. All right? Is my slope going to be positive or negative just looking at it? Negative. So I'm going to count down 1, 2, and over 1, 2, 3, 4, 5, 6. So my slope is going to be negative 2 over 6. Can I reduce that? Yes. So what's the slope going to be in my equation then? Negative 1/3, and I always put my x. The next piece of this is I need to know my y-intercept. So I'm going to look at the graph. It crosses the y-axis right here. What is that number? It's negative 1, right? Negative 1. So it crosses at negative 1. So the rest of that equation is going to be minus 1. Negative 1/3 x minus 1. So looking at the graph, you can come up with what your slope and your y-intercept is, and you can actually write the equation of the line in slope-intercept form. So go ahead and do that second one there. Find your slope, find your y-intercept, and then write your equation. So it says write y equals 3 in slope-intercept form. State the slope and y-intercept and graph the equation. This is a special equation. Where is my x? I don't have one, right? So technically, if I wanted to write this, did I change it? No, if my x is not there, I must have a 0 in front of the x, right? And so this is technically slope-intercept form. Like this is technically a valid slope-intercept form because my y is by itself. Which means my slope of any line that has just y equals some number, my slope is always going to be 0. Always going to be 0 when you just have y equals some number because my x has been zeroed out. All right, my x has been zeroed out. My y-intercept of that type of line is always going to be that number. It's going to cross the y-axis at 0, 3. And this is a special type of line. What type of lines have horizontal? What type of lines have 0 slopes? It's horizontal, right? And so just like from homework, when you had that horizontal piece on your graph that had a 0 slope. So anytime your slope is 0, it is going to be a horizontal line. So we're just going to go to the y-axis at 3. We know that's where it's going to cross. If it crosses there, it means it's going to be horizontal there. And so it's always going to look like this. Anytime you have y equals a number, it will be a horizontal line at that number. on the y-axis. Your slope will always be 0, and your y-intercept will always be that number. That's where it's going to cross. So you can have any form. You can have it in slope-intercept form. You can have it where it looks like it's missing the b. Well, that just means it's a 0. It's going to start at the origin. You can have where it's missing the x. That means it is a horizontal line, y equals 4. And then you can have one that's not in any form at all. It's not in standard form. It's not in slope-intercept form. And you may have to write it out and move something over. So you may have to subtract something, divide by something to get it in a form that is usable for you to work with. And so it's possible to have any one of these types of lines. All right? So just because it doesn't look like it's where it needs to be, you may be able to work it out, or it may already be in the form that you need it in.